All right, today we're going to be talking about quadratic functions, and specifically we're going to be working with vertices, right? We want to talk about the vertex of the parabola, which is either going to be the minimum or the maximum point for a quadratic function. We're also going to discuss the axis of symmetry, the domain and range of parabolic functions, and intercepts, right? How the x and y intercepts might help us or can be found either from the equations or from the graph. So recall that a quadratic function is of the form ax squared plus bx plus c, and a, b, and c are all real numbers, and a is not allowed to be 0, right? Because then that would wipe out the squared term and it's no longer parabolic. Okay. So the graph of a quadratic function forms a geometric pattern called a parabola, which we've discussed. And the standard form for a quadratic function is f of x equals some constant a, where again, a cannot be 0, times the quantity x minus h squared plus k. The vertex, which is where the parabola intersects the axis of symmetry, or is going to be its minimum or maximum point, depending on whether it's opening up or opening down, can be found by the point hk. And that's if it's in standard form. If instead the quadratic equation is given to you in ax squared plus bx plus c form, then in order to find the vertex, we need to use these formulas. It's the opposite of b over 2a for the x coordinate. Okay, so x equals minus b over 2a. And then the y coordinate is the function evaluated at minus b over 2a. Right? This axis of symmetry that we mentioned before occurs at x equal h. So it's an x equals equation that the parabola is symmetric. If the coefficient a is greater than 0 in either of the two forms, whether it be in the standard or in this other form, the ax squared plus bx plus c, then the parabola is said to be concave up, and the vertex is a minimum. Okay. And that's going to be this image right here. And that's what we're used to when we talk about parabolas, right? If the constant a is greater than 0, then the parabola opens up, which means it's concave up, and the vertex is a minimum. Now, if the constant a is less than 0, then the parabola is now concave down, and the vertex is a maximum. And that's this image right here. Okay, so this opens down, and the vertex is a max. So we're going to be asked to find a bunch of things for quadratic functions, both in standard form and in the, I guess I'll call it the normal form, what we're used to for a quadratic. This first example here is in standard form. So remember, from above, that's a times the quantity x minus h squared plus k. So let's just jot that down here, right? In standard form, this is a times x minus h squared plus k. And the vertex, recall, is the point hk. Okay. All right. We also notice that in this case, a equals 2. And we can go ahead and pull off h is 3, k is 4. All right, so then the first question says, find the coordinates of the vertex of each parabola defined by the given quadratic function. Well, we just found HK, so our vertex is at the point 3, 4. Second question says determine if the parabola defined by the given function is concave up or concave down. Well, A is greater than 0. So again, if we go back up, A greater than 0 is concave up. Also note that this means we have a minimum. So A greater than 0 is concave up. The third question says, determine if the vertex is a minimum or a maximum. Well, if it's concave up, that means it opens up, and that means that the vertex is a minimum. The next question tells us, find the axis of symmetry. Remember that the axis of symmetry is defined by x equals h. So in our case, this is x equals 3. And when we're all done with this, I'll go ahead and plot this function so we can see all these things. Okay. Fifth part of the question, give the domain. Well, this is a parabola, and even though we don't know what it looks like, right, if we look at the function, there's no restrictions on x. There's nothing that we're not allowed to plug in. So the domain, like many other instances, is all real numbers. Question 6 says, give the range. Now, this is what the y values can be. If the vertex is a minimum, that means that's as low as we can go in the y direction. And the y in the vertex is 4. That tells us that our range starts at 4, and we can equal 4, and we'll go all the way to infinity. All right, if it opened down, then we would go from minus infinity up to 4, for instance. All right. And the last thing here says, find the intercepts of the function. So there's a couple different ways we could do this. I am going to see if we can't solve it. So let's do, for one thing, if we want the x-intercepts, then we need y to equal 0. So x-intercepts, y is 0. So we're going to set the function equal to 0 and solve. Now, when this is in this form, it's a little easier to solve. Right, I can subtract 4 from both sides of the equation. So negative 4 equals 2 times x minus 3 squared. Divide through by 2. Okay. So we have negative 2 equals x minus 3 squared. Now note that we have equals a negative, and I'm about to take the square root. So when I take the square root of both sides, look what happens. Now, again, when you take the square root, you get plus and minus, but I have the square root of a negative number. So what that tells me is that I need to bring I in, right, which we just learned in section 2.1. So continuing to solve for x, I would add 3 to the other side. So I end up with 3 plus or minus square root of negative 2. And that's plus or minus I square root 2. So the two solutions are 3 plus I root 2 and 3 minus I root 2. So what does that mean if we get two complex x-intercepts? Well, that should mean that our parabola does not touch the x-axis. And that should make sense if you think about the vertex, right? The vertex started at y equals 4, and it opened up, which means it's above the x-axis, okay? We still need to find the y-intercept. So to find the y-intercept, we need to let x equal 0. So now we have y equals, and this is 2 times 0 minus 3 squared plus 4. Okay. Negative 3 squared is 9. 2 times 9 is 18. 18 and 4 is 22. So the point is 0, 22. Okay. So let's hop on over to Desmos and see if we can make sure that our vertex, our intercepts, all of the things that we found match up with the graph. All right, so I've went ahead and graphed our function over here. You'll see that our vertex is indeed at 3, 4. And you'll see that we touch the axis at 0, 22, or the y-axis. That's our y-intercept. You also notice this thing opens up or concave up, and therefore our vertex is the minimum. And then lastly, we do not touch the x-axis, and that's why we have 2 complex roots. All right, for our second example, this time we are not in the x minus h plus k form. So instead, we need to find our vertex by the formula minus b over 2a, f of minus b over 2a. Okay, so find the coordinates of the vertex of the parabola. So in this form, this is ax squared plus bx plus c. Therefore, a is equal to negative 1, b is equal to 8, and c is equal to 1. Now keep in mind, this is the same a, b, and c we would use if we were using the quadratic formula to solve, which we might do here in a moment. Okay, so we have ABC. For the x coordinate, we need to do minus b over 2 times a. All right, so it's minus b over 2a. So that looks like we're going to get 8 over 2 or 4. Okay, now we need to plug that into the function. So we need, in this case, g of 4. So that's going to be minus 4 squared plus 8 times 4 plus 1. So that's minus 16. Then 8 times 4, that's going to give us 32 plus 1. So it looks like we're going to have 17. So our vertex is the point 4, 17. All right. Second question. Determine if the parabola defined by the given function is concave up or concave down. Well, in our case, a is less than 0 because it's negative, and therefore this is concave down this time, which means it opens down. If it opens down, then for the third question here, where they ask us about the vertex is now a maximum. Okay. For the fourth question, find the axis of symmetry. The axis of symmetry was x equals h, or since we don't have h in this case, it's just the x coordinate of the vertex, which is 4. Right. Well, these two values that we found, even though they're defined by minus b over 2a and the function evaluated at that, are nothing more than hk. All right. So x equals 4 for that one. Then question 5, give the domain of the function in interval notation. Again, it's a parabola. It doesn't care what values of x we plug in. And so x can be anything from minus infinity to infinity. What about the range? Well, this time our vertex was a maximum, which means we can be anything below it up to y equals 17, and we can't go any higher. All right, the last part is define the intercepts. So I need to set the function equal to 0. So this is 0 minus x squared plus 8x plus 1. Okay, now to solve this, I could try to factor, or I can use quadratic formula. So let's just try quadratic formula. Obviously, you'd factor if that was easiest. Here we would try to make something that is multiply to -1 and add to 8. That doesn't seem like that works too well, so let's try the quadratic formula. Okay, so I have x equals opposite of b, so -8 plus or minus the square root. Right, so then we need b squared, so that's going to be 8 squared minus 4 times a times c, all divided by 2 times a, which is -1. So we have -8 plus or minus square root 64. And then this is going to be plus 4 all over -2. So we have plus or minus square root of 68 all over -2. All right, does a perfect square go into 68 nicely? All right, so 68 is 4 times 17. So we have -8 plus or minus square root of 4 times 17. All right, that can reduce. You can bring out the square root of 4 as a 2. And then breaking this up into 2 parts, we have this. So -8 over -2 is 4. Then we have plus or minus. And then we have 2 divided by -2. So what I'm going to do is, if I divide by a negative, that really just kind of flips this around to minus and plus. Doesn't really matter. But this is root 17. Right, if it's plus or minus a negative, you're eventually going to make 1 plus and 1 minus. So we can just make this plus minus. So those are my two x-intercepts. They are 4 plus root 17 and 4 minus root 17. Not the prettiest things we've seen, but not awful. All right, lastly, we would need to find the y-intercept, and we do that by plugging x equals 0 into the equation. So for the y-intercept, we say y equals, we would have -0 squared plus 8 times 0 plus 1. And that's really nice. This is 0. This is 0. And we just get 1. So the y-intercept is the point 0, 1. All right, again, let's go ahead and jump over to Desmos and make sure that the graph and all of these things that we just found seem to make sense. So our equation was minus x squared plus 8x plus 1, if I remember correctly. So we're looking for the vertex to be 417. That's correct. That's that point there. We touch the y-axis at 0, 1. We touch the x-axis, it looks like, at -0.123 and 8.123. Now let's see if that is the same as the 4 plus root 17 and 4 minus root 17. Right, so we have 4 plus root 17. That's 8.123. And then if we switch this to minus, we get negative 0.123. So indeed, right, we are at the correct values. Again, this is concave down. The vertex is a maximum. Everything we found looks good.